Welcome to the first course of Six Sigma Black Belt. We're going to be building on the Green Belt lessons and reviewing a lot of the Green Belt and then actually applying it. So this is the first lesson. So what is the value of Six Sigma? What is Six Sigma anyway? Well, it's a disciplined approach, and you develop products and services that are near perfect. Back when I was a kid, we just expect things to break. Now we get upset when the cars break down. This is a strategy for management, and they're using these statistical tools and project management tools to gain breakthrough business metrics, and we'll talk about that later. But these have been around for a long, long time, and tried and true. And it's a management by fact, database-based approach that allows organizations to do the management by fact, which is key to all world-class companies. And the focus is on the customers. Ultimately, it's the customer that decides if our business or organization lives or dies. Just a real brief history of Six Sigma. Basically, it's the history of quality, but the concepts of the tools and stuff, the statistical tools, have been around for a couple hundred years. Early in the 19th century, Gauss started doing this with the normal curve. In the 1980s, Motorola picked this up. Bill Smith, who was a Naval Academy graduate, came up with this yield theory. He basically said it's not just how much fails at the end, but it's how much you're losing in the entire process. He calls that the real throughput yield. Well, he starts talking to another quality guy, Michael Harry, and Michael Harry says, well, look, we need to do this Six Sigma quality. And Six Sigma comes from the statistical term for standard deviation, and they published this thing in 1986. Motorola then coins the word Six Sigma, and they won the Baldrige Award in 1988. Basically, at the time, Motorola leapfrogged the competition in telecommunications as a result of Six Sigma. And the first step is that is define in the DMAIC cycle, define. And this is where you develop a very focused problem statement that describes in measurable terms what the project will deliver. The old adage, what gets measured gets improved, is true. So you want to know exactly what you're going to improve. And you need to put a number on it, be able to measure it. And the process for doing that in Six Sigma is generally done with a project charter. And these things vary quite a bit. I'll show some examples in the reading. So you want to know where you get it started. So what you do is you want to document where you are now and get a baseline. This is the major part of the process. And in this phase, you gather data. And again, data is a plural, right? And you want to focus on the response variable. If you remember the old algebra formula, y would be the response variable of the independent variable of the x's. So you want to see how you're doing overall, get the big picture. And then you start analyzing. And this is where you get the math and the metrics and all the statistics. You look at the top causes behind this. These are the x's. And you dig down and find the root cause. And it's not just a guess. Very mathematical. You can actually see how strongly what you suspect are the root causes relate to the response variable. Very easily. Well, not easily, but that's the whole goal of Six Sigma. I'm going to walk back a little bit. It's not the whole goal of Six Sigma. That's the whole point of the analyze part. Then you say, okay, these are the causes. How do I make sure that I can improve the process? So those things that are causing us problems, headaches, whatever it is, we start looking at. And Six Sigma is all about reducing variability. It doesn't matter if it's a variability in the process, variability in the quality, variability in anything, right? Product or process, you reduce the variability. So we're going to measure that variability, and then we're going to reduce it. I wish I had a nickel for every time I did an improvement project, and then I went back and did the same thing again and again and again. This is the part that gets you sustain the changes made in the improvement phase. All right? Best controls which require no monitoring. In other words, you change the product or process design so they can't screw it up or change it back. Okay? One of the simplest things I ever did was took away a desk where they're storing all their little secrets and stuff. Very easy. Sneeze said there are some reasons for doing Six Sigma. First thing is bottom line results. When I first started doing this in the 1990s, I wasn't real impressed with it because it just looked like good old-fashioned quality engineering. But what they did is they brought in the financial part. How much is it saving us? And once you start doing finances, then senior management gets interested and get involved. It's very disciplined. Most projects last less than 6 months, and it's management by fact, which is a world-class trait of organizations. World-class companies are database driven. Builds infrastructure. We're talking about cultural infrastructure, intellectual infrastructure. We're talking. This is the kind of stuff that you just can't buy. Customer focus. Ultimately, customer decide if we're good or not. And the mathematics have been around for a couple hundred years. I labeled this slide Six Sigma Gurus, but most of these guys never even heard of Six Sigma. If you look like Philip Crosby, he wrote a book in the 1960s, I think it was, Quality is Free. He showed how much quality problems fail, or poor quality, how much it costs a company. Edward Deming, Joseph Duran, and Walter Sheward actually worked together in Western Electric, and they analyzed variability of processes, and they came up with SPC. Deming and Duran actually went over to Japan and taught this to the Japanese. The Japanese applied it to get their quality up. In fact, the highest quality award in Japan is still called the Deming Prize, named after an American. Feigenbaum, he did the TQM. Ishikawa, he does the root cause analysis. Taguchi, he came out with the orthogonal arrays that we use in our DOE, or design of experiments. Of course, he talked about Bill Smith and Michael Harry at Motorola. Okay, these are some lean pioneers. Frederick Taylor, he did the time motion studies in the 19th century, early 20th century. Henry Ford, we all know what he did, put the assembly line, put everything in its place in a proper order. It was his model. He knew that time was money. There are 3 members of the Toyota family. Notice it's Toyota, but it's spelled the D in this case, but it's actually Toyota, the car. Ono and Shingo, they all came up with the Toyota production system. The 7 wastes you saw in the handout, they all came out of these 5 people. James Womack and Daniel Jones started a company in 1991, I think it was. One of the best lectures I ever had was a guy named Dave LaHote, who worked for those guys, and they called it Excellence in Manufacturing. And what he did is he basically took the Toyota production system and brought it to America. Brilliant, brilliant, brilliant guys. Now, Lean and Six Sigma, they complement each other very, very much. Six Sigma is all about reducing variation. Lean is reducing the 7 waste. And by doing that, you get more efficient. Six Sigma is achieving near perfection. The savings, the cost of poor quality is Six Sigma. Lean is the operating cost. Six Sigma is tough. I mean, the math in it is not easy. Lean, the nice thing about Lean, it's relatively a short learning curve. It's easy to conceive in what's happening there. Various projects for Six Sigma. Lean is value stream mapping. Six Sigma takes about 2 to 6 months. And the more you use it, the better you get at it, of course. And Lean, you can learn that in less than 3 months. It's data-driven for Six Sigma. And Lean, with the meaning by demand, is customer demand. What does your customer expect? 3 big things: price, quality, service, or selection. Those 3 things, that's what your customer wants. That's what drives Lean. Six Sigma can be very, very, very complex and detailed. Lean, it's just generally just very simple usually. In fact, you want it to be simple. These are the Lean Six Sigma tools to define, measure, analyze, improve, control. Take a look at them. Just pause and take a look at that. I'm not going to go over them, but just take a look at it. You know, one of the these are organization goals. You turn them into projects. Good projects increase productivity or quality. be careful with that profitability. You know, one of the worst things that could happen to a company is they make money, but they don't do it very well, but they just somehow manage to make money. And they think, oh, if I'm making money, I must be doing it right. But there's always a better way to do it. Some quick examples: cost savings, satisfaction, processes, lingering problems, location. By that we mean not everything's in its place like Ford wanted. Your design is screwed up. Oh, and suppliers. Oi. This is the definition of a system. It's a collection of parts or subsystems integrated into and accomplish an overall goal. A system of people's organization. And if you got a factory or anything, you got machines and its people, they're integrated together, right? So the parts become the people also. And I just pulled this off from the project management. Very, very, very simple system, organizational. And the key thing on that I want you to notice is feedback, effective feedback. You got to know how you're doing. This is a picture we used in the Baldridge when we get trained in it, and if we were going to do an application. One of the things the Baldridge noticed in the 1980s, that world-class companies do 7 things very well. And you can see it's leadership, strategic planning, customer and market focus, workforce focus, process management, results, and finally measurement and analysis and knowledge management. And we call this the big hamburger. The measurement, analysis, or knowledge management, in other words, the facts and the data, that's what this whole organization is built on. The organizational profile, environment, and relationships and challenges. That's, do you really understand what your business does, why it even exists, and what are the threats to it? We're going to talk a little bit about SWOT later on. And generally, this is just a partial list of what business must do. They've got to do all of them very well. And what we want to do is break this big organization into small bites. So here are your little bites you can look at. Then you break these little bites into even smaller bites. You're going to chew it. It's kind of like eating an elephant, one bite at a time, right? Take a look at it. Pause. And here it is. This is the SWOT analysis: strength, weakness, opportunities, and threats. And so what you want to do then is you go through this. You say, what are your strengths? And I'll let you read the list. What are your weaknesses? Some questions you want to answer there. Opportunities and threats. And it's both internal and external, right? And it's not, it doesn't matter how big the organization is. When I was a one-man consulting firm for a while, I did this, right? Take a look at it.